Hello friends, today the topic which we are going to discuss is hexadecimal number system, and in which we try to convert our decimal number to hexadecimal number, and an hexadecimal number to be converted into decimal number, and decimal number to binary, and a binary number to a decimal number conversion. Okay, so in the previous videos we have seen how the number is converted into octadecimal or binary number conversion in the converted to a decimal number system. So if you haven't watched those videos, please do watch the previous videos, and you can see easily understand. Okay, for converting a decimal number to hexa, or a binary conversion of a decimal number system, or okay. Okay, hexadecimal number system, as the radix value of that hexadecimal is 16. Okay, that means the numbers in this hexadecimal system will be having symbols where it can be represented from 0, 0, 1, 2, 3, 4, 5, 6, 7, up to here. We can see the numbers are as like decimal number systems, and from 9 onwards it will be represented as A, B, C, D, E, F. Okay, so whatever numbers which in hexadecimal number will be represented from 0 to F. Okay, so as A is corresponding the decimal number 10, so generally in decimal number we write after 9 we write 1 and 0. That means, so 0 to 9 it is completing a decimal number, a 10 number. Okay, so after 9 we'll have, in the place of units we have 0, and in tens place we have 1. Okay, so this decimal number is represented like A in hexadecimal number, and 11 will be represented as B, 12 represented as C, 13 will be represented as D, 14 will be represented as E, and 15 will be represented as F. So if you count 0 to F, we have 16 values, 16 symbols. So that is why the radix value of this hexadecimal number system is 16. Okay, so let us consider an example for a hexadecimal number. As you can see, the number is 7A here. So this 7A is a 2-digit hexadecimal number. So in this, each digit of this is a multiple of a 16. As you can see, as I have written 0 and 1 on top of it, so 0 and 1. So these power values will be having on top of this 16. Okay, so 7 into 16 power 1, and A into 16 power 0. 7 into 16 plus A is corresponding number, decimal number equivalent value is 10. So 10 into 1. So 7 16s are 112 plus 10 is equal to 122, which is decimal equivalent value of this 7A. So we will take another example for this. So CE. So CE is, so you can see C is 12 and E is 14, right? C is 12 and E is 14. C E nothing but if I write C is 12 into 16 power 0 and 1, 16 power 1 plus E, that is nothing but 14 into 16 power 0. Okay, so 12 times of 16 is 1 plus 12 is 32. So 192 plus 16. This value is 1. Okay, so the value will be so 192 plus 14, which is nothing but 206 base 10. So this is a decimal equivalent value of this hexadecimal number CE. So we have a comparison table of this 4 decimal or 4 number systems which we discussed previously, that octadecimal, decimal number and binary number and hexadecimal number. I am writing all these numbers in a table format. As you can see, the binary number in this is represented with 4 digits. So we will discuss why we are denoting with 4 digits. So as in octadecimal number system, the binaries will be represented with 3 digits. Okay, in 3 digits will be represented for octadecimal equivalent value of the binary. Okay, so this table is very important. Try to remember it, and it will be helpful for learning how we convert a binary number to a hexa and a hexa to binary conversions. So as you can see, I have written the binary decimal number values from 0 to 15, and binary values from 4 zeros to 4 ones. So the numbers will be from 0, 4 zeros to 4 ones. Okay, so decimal numbers are from 0, 1, 2, 3, 4, 5, 6 to 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So the numbers, decimal values from 0 to 15, and the binary values, these are equivalent numbers. So in decimal number, for decimal number 16, so binary values will be written as 4 ones. Okay, the same decimal equivalent value, decimal value 15, octadecimal equivalent value is 17. As you can see, octadecimal value will be from 0 to 7. So after 7 we have 10. So if I try to convert this 10 into decimal equivalent value, I will have 8, because 10 into 10 multiplied by, so 10 value will be an octadecimal, right? So 1 into 8 power 1 plus 0 into 8 power 0. So the decimal equivalent value is 8. So for 8 we have 10 here. So in the same way, hexadecimal value will have same 8. But if you see for 10, decimal equivalent value 10, in octadecimal it is 1, 2, because 1, sorry, it's 12 base 8. So 1 into 8 power 1 plus 2 into 8 power 0. So which is nothing but 8 plus 2, which is equal to 10. Okay, so decimal value 10, in octadecimal value it is 1 2, in hexadecimal value it is A. Okay, so in this way we will write all these values. So please do remember this table, and it will be helpful when you convert your binary conversions and decimal number conversions. Okay, decimal to hexa, hexa to octal, octal to binary, so whatever. So this table will be helpful for you. Please do remember this table. So the topic which we are discussing now is decimal to hexadecimal conversion. So for decimal value we'll have base 10, and this base 10 value will be converting into base 16 value. So how we will do, as we have discussed in octal conversion and octadecimal conversions, the same way the LCM of this 28, as you can see, the before the decimal point the number has to be done, and then the number has to be LCM. Okay, so 28 will be divided by 16, which is the radix value. Okay, so after decimal point, that which is nothing but 0.6875, will be followed by multiplication method. So we will multiply this entire value 0.6875 into 16. So we have two methods, that is LCM method and multiplication method. So 28 divided by 16, so 16 ones are, and we'll have a remainder with 12. And for our convenience I have written this 1 here, and I have kept 0 hyphen 1, and we have to write the value from top to bottom, sorry, bottom to top, right? So from this is MSB, MSD or MSB, MSD, and this is LSD. But if you write 1 and 12, we will have 112, which is wrong. We need to write this 12 in hexadecimal value. So what is the value of 12 in hexa? So 1, so A is 10, B is 11, C is 12. So 1C base 16 we have to write. So 1C base 16, and if you multiply this 0.6875 into 16, we have 11.0, which is nothing but carry. So this carry also should not be written. If I write in the same 1C.11, if I write this, answer is like this. This is wrong. So 11, we should not write directly 11 value, we need to write hexadecimal equivalent value. So 11 is B. So the answer will be 1C point B base 16. Okay, this one is correct one. So this one is correct. Okay, we need to write decimal equivalent values. Here we have written, instead of 12 we have written C, and in this carry we have got 11, and this we are writing this 11 value as B. Okay, so the answer is 1C point B base 16. So we need to write as base 16 represents the hexadecimal value. So this value is hexadecimal value. So let us consider another example. 873.70 base 10 which has to be converted into hexa. This number has to be converted into hexa. So for 873 we need to follow LCM, and this 0.73 0.75 we need to multiplication method. Okay, multiplication method follow. So when I divide 873 by 16, so 1654 is 864. So 54 times 864, which remains with remainder 9. And if I divide this 54 by 16, 16 3 is 48. So I will have a remainder 6. So 16, if I write this 3 here and break this, so if I write this same number 369 is a hexadecimal number. Okay, 369 is a hexadecimal number. So now I am doing this 0.75 into hexa, converting. So 0.75 into 16 is equal to 12.0. So this 12 hexadecimal equivalent value is C. Okay, so if I write the same 873.75 decimal number, which is converted into hexadecimal number, which is nothing but 369.C base 16. Okay, so now we are trying to convert hexadecimal number to decimal number conversion. So as we have discussed in the previous videos, octadecimal to decimal number and binary to decimal number, as we have discussed that expansion method. So any radix value which has to be converted into decimal number, we need to follow expansion method. So I am taking an example. For example, a hexadecimal value 10. So 10 base 16. So if there is a base value 16, that means it is a hexa value. Okay, if I write only number 10, I haven't given any base value, then you need to consider it as a decimal value. Okay, if I have given the same 10 value with base 8, then it is a octadecimal number. And the same 10 value, the base is given 16, then it is a hexadecimal value. So there is a difference. Okay, or the same binary 10 value is given base 2, then it represents a binary value. Okay, so this hexadecimal value 10, if I write the power values 0 and 1, and I multiply this 1 into 1 into 16 power 1 and 0 into 16 power 0, so 16, so this value will be 1, and 0 multiplied by anything is 0, so this value will be 0, and we have only 16. So the decimal equivalent value of this hexadecimal number 10 is 16. Okay, so we take another example 24. So now if I take 24, so as you can see, same power values are written on top. If you want, I can write 0 and 1. So 2 into 16 power 1 plus 4 into 16 power 0, 2 into 16 and 4 into 1. So 2 16 is 32 plus 4 is 36. 36 is the decimal equivalent value of the hexadecimal number 24. Okay, if you understand this, try. So I am again getting into hexadecimal values B. Now I am not representing from 0 to 9. I am going beyond 9. Okay, now it is the value BE, the same hexadecimal number BE. So I am multiplying the power values. If I write as 0 and 1, so B into 16 power 1, which is radix value. Okay, E into 16 power 0. So B is nothing but 11 in decimal number, decimal equivalent value, and E is nothing but 14. So 11 into 16 is 176 plus 14 ones are 14. So if I add this value, I have 190 base 10. Okay, whenever expansion method is follows, that then it is a decimal value. So that is why you have, see, we can see I have written base 10 on the bottom of the number, 16 base 10 and 36 base 10, 190 base 10. Okay, if suppose if I take a hexadecimal value with decimal point values, so you can see an example. I have taken 3D.7a base 16. So I'll say expansion process will be followed here. So as you can see, 3 into 16 power 1, as I have written the power values from before the decimal point, the value goes from 0, 1, 2, 3, and for fractional values, the values will be from -1, -2, -3, -3, so on. Okay, so 3 into 16 power 1 plus D into 16 power 0 plus 7 into, so as a fractional value of the radix value 16, so that is the power value of 16 power -1, and A into 16 power -2. Okay, so 3 into 16 plus D value is, decimal equivalent value is 13. Okay, and 16 power 1 is 1. So 7 into, I have written these values, 16 power 1 value is 1 by 16. So 1 by 16 value is 0.0625, and 16 power -2 value, that is 1 by 16 square, that is nothing but 1 by 256 value. So 1 by 256 value is 0.0039065. Okay, if I substitute these values here and I multiply here, I multiply with these values. So 7 into 0.0625 is 0.4375, and 10 into 0.0039065 is 0.0390625. So if I add this value, I have 61.4765 base 10. Okay, if you understood how this process is followed, please do this example B9FC base 16. Okay, so the base value is hexadecimal number, so base 16, and try to get the answer for this. Okay, thank you. So now we are trying to convert the hexadecimal number to the binary conversion. So in binary conversion, in octadecimal value, we have represented the binary codes in for each octadecimal number with 3 digits, right? With the 3 digits, we represented our octadecimal number. For 0, we have represented with 3 binary codes, 1, so on, 7, 1, 1, 1. So in the same way, in hexadecimal we represent each hexadecimal digit with 4 binary codes. So that is why in the previous table, as you have observed, so binaries will be represented with 4 binary codes. Okay, so with considering that binary code of each hexadecimal number can be represented, so I am taking an example 8D.3 base 16, which is to be converted into binary. So I have written each digit 8D.3. So each hexadecimal digit will be represented with 4 binary codes. So the binary code of this 8 is 1000, and for D is nothing value but decimal value is 13. So the 13 value and the binary code value for 13 is 1101, and 3 is 0010. So if I start writing this entire binary code, so I have the complete binary code as 100. So 10001101.0011. So base 2. So base 2 value is representing the binary value. Okay, since it is a binary value, we are writing the base 2. So we take another example, converting hexadecimal to the binary. So example is 93.CB. So I am writing each individual hexadecimal number. So 93CB. So 9 will be represented as 1001, and 3 is 0011. So C is nothing but 12. Okay, C is nothing but 12, and B is 11. So decimal values. So binary equivalent values of this hexadecimal number B, you can write from table C and B. So as you can see, C value is 1101 and B value is 1011. Okay, so I can write from this table, or else simply you can convert decimal equivalent value with binary. So value is C is 12 is 1100, and B is 11, nothing but 1011. Okay, so if I write the entire value of this, I will have 1001.10 11001011 base 2. Okay, so this is the binary equivalent value of hexadecimal number 93.CB, which is converted to binary. So if you understood the process of converting, please try this example and get the answer for it. Okay, so now we are trying to convert the binary to hexadecimal number. So in the previous one we have converted hexadecimal to binary. Now we are trying to convert the binary value to equivalent hexadecimal number. Okay, so if I have an example, so here we group, so we say the simple rule we follow here is we group 4 digits from LSB to MSB. So here the LSB value is this one. Okay, so LSB is this one, and this is MSB. So as you are grouping, so you need to group from LSB to MSB. So I group 4 digits. Okay, after decimal point we need to group 4 bits. So I have written it in on the bottom like this. As you can see, we have in this last 10 we have only 2 bits, and in this 01 bit also. So in this group and in this group we have only 2 bits. So what we need to do is we need to replace this remaining bits with 00. Okay, so we need to replace those bits with 00. So if I replace those bits with 00, so every group will be having 4 binary bits. So with this, the above 10 bit will be becoming 0010, whose equivalent hexadecimal value is 2, and 110 hexadecimal equivalent value is C, 101 is 9, 1000 is 8, 0100. So after substituting these 00 values, so this value becomes 4. Okay, so if I write the same as a group 2C9.84, don't forget the decimal point in between. Okay, so base 16. Okay, so we have another example also. So example is like converting 100 sorry 11001111.10101 base 2. It is nothing but this is a binary value and it has to be converted into hexa. So first of all we need to write the entire binary number and try to group 4 digits from LSB to MSB. So as you can see, I have grouped 4 bits. So this has 4 bits and this has 4 bits, and in this last one we have only 2 bits only. So I have replaced it by 00, and in this also on the left hand side also. So 1010 is having 4 bits and this bit is having only 1 bit. So I have replaced other 3 bits with 00. So after replacing with 00, the every bit has 4 binary bits. So if I write the hexadecimal equivalent value of this each binary value here, so 0011 value is 3, and 0010 is 2, 1111 4 ones is F, 1010 is A, and 1000 is 8. So after completing grouping and making hexadecimal equivalent value, I can write 3 to F point A 8 base 16. Okay, so try to convert this example which I have given here. So you can group 4 bits and try to get the answer for this, and we'll see in the next video uh, binary multiplication, arithmetic operations of these binary operations. Okay, binary operations, like we'll convert how binary can be multiplied, divided, subtracted. So in subtraction process we will generally use a complement method also. So we go through for one's complement method and the two's complement method, and then so in the next video we'll discuss about all these topics. Okay, thank you.